Welcome back to the studio. Today we are going to continue talking about callbacks and make it a little more interesting with a for loop. Let's get started. This is where we left off last class, and basically we were able to set a node. So set a node in the world with respect to the position that you placed your first node. And some of y'all messed around with this and made the node that it was placing it be itself, and that's a lot of fun, really cool. It might cause some trouble with this lesson, and so what I would recommend is changing that back to just some sort of default dirt or default message, something else other than itself. And then once we've made it through this lesson, then you can switch that back and just see what happens. Just quick disclaimer. So like I said, I want to integrate a for loop because right now we're only placing one block. But what if we wanted to do a task over and over and over, such as placing or setting a node? How do we do that? Well, if you remember back to our lessons on Lua, there are things called loops. And we're going to use a particular loop, a certain loop, called the for loop. And so now, before we actually use that for loop, we got to think through, or before we write the for loop, we got to think through what code we want to sandwich inside of the for loop. And so if you think about it, we want to place nodes not in the same spot, but on like different spots. And so we're going to need to change this, which is the distance. And I actually want to change this name to offset. It makes a lot more sense because that is the distance that the node is going to be offset from the original, right? So if we write that, offset, great. So the offset is some sort of distance. And so that's going to need to change in our for loop. Every time we loop, we're going to need to change that offset value. And then do the addition, the vector addition, which is line 12. And then finally, we will actually set, based on the new position, that node. And we're just going to stick with a static node. We won't be changing that up. Okay, so let's go just above the declaration of the offset variable and type 4. And thanks VS Code, it gave us some auto completion options. Let's go to the bottom one, click enter, and there we have the meat of or the framework, I should say, of our for loop. We're going to grab the meat, which is this stuff here. Press Control C, or Control X in this case. We want to delete. Go up here and paste. Now, to keep everything looking nice, I would recommend that you highlight the last two lines of that code and press Tab. That just tabs a large section over at the same time. If you had a lot of text, it would be much more useful. So just something handy to throw in that tool bag. Okay, so here we have a for loop. It's going to run several times, but hopefully maybe you have noticed that we haven't changed up the offset. So it's just going to place in the same location every single time, and that's just absolutely useless. So let's look at the anatomy of the for loop real quick. Here we have some sort of variable that is set equal to 1. We have a 10 and a 1. If you remember in a loop, what these numbers signify is a start value, the end value, and then the increment size. So it's going to start at number 1, and then it's going to increment by 1 all the way to 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and end on 10, I believe. So that is what the for loop creates. It creates this variable called I. Now, if you think about that, here we have some numbers here. Here we have some numbers that are being assigned to the X, Y, and Z. They're simply numbers, and so we could change it up to a 3 or whatever we wanted. What if that number were to change while we're running this code? What if that number were to go from 1, 2, 3, 4? Do you see where I'm going with this? In our case, we can stick the I there. If we put the I right there, then that value will change from a 1 all the way to a 10. What'll happen in our in-game then? Well, let's save this. Head over to Minetest. Make sure you restart the world. Don't have to refresh your mods, enable and disable. You don't have to do that. You just have to get out of your world and get back in. And let's just see what happens. Okay, here I am in my world, and I place it, and voila. It adds 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 blocks. As expected, 10, right? So if we went back over to our code, you could play around this and change maybe the 10, make that like 100 or whatever, or, you know, ridiculous value. Probably bear in mind it'll probably crash the game. But instead of just doing that, I was thinking it'd be kind of cool not just to place a string or just a long length of blocks, but a flat surface, like a flat plane. And so what the big disclosure here, the way you do that is by nesting a for loop, okay? I'm not going to do all the work for you. I'm going to kind of set you up, and then you'll have to finish and kind of place things where they need to go to make this happen. This is the assignment, though. But before we actually bring out another for loop and nest it, let's go over what we've done so far. This code right here is used to define a location in the game and then set that location as a node, as the node that we specify. We manipulate or we change the position with these values. The Y is in the up direction. So if we were making a plane, we would want to be changing the X and the Z. That would create a flat plane, okay? So we've done the X already. Now, if we did the exact same thing again, creating a for loop, taking this code, putting it inside of that for loop, theoretically, we should be able to achieve what we're trying to achieve, okay? That is called nesting, is sticking a for loop inside of a for loop. So I'm going to set you up here. So we're going to write, we're going to go just below the first for loop declaration and then type out for all the way down to the bottom, press enter. And one quick change here is you see it's selected I. We can't use the same variable. We can't use that. It's being used by the first for loop. So we're just going to go with J. I, J. It's just a convention. People do it. So there we have the second for loop. Now, what needs to go inside of it? Think about what we just did and put the code inside of it. And then change up the necessary values in order to get it to create a flat surface. I'm going to pause this video, do all the work real quick, and then just show you the end results and what you should expect to see. Okay, so we're kind of out away from everything. And there, when we place the node, it creates this flat plane, which is very nice. Now, from here, that is what you're going for. From here, you can play around with the code. You know, I mean, at your own risk, have it place itself. I think more than likely it will lag out your game, possibly lock up your computer, and then you'll just have to kill the computer and start over. So just bear that in mind. Thanks for watching, guys. Until next time.